We're asked to determine whether the integral is convergent or divergent, and perhaps the first thing we'll notice is that the lower bound is negative infinity. This is a very unusual situation. It's known as an improper integral, and the first thing we need to do is replace the negative infinity with the variable t, but then simultaneously take the limit as t approaches negative infinity. So this is just really another way of writing the problem. It's more notational than anything else. Our upper limit, of course, is still 0, and then we have to integrate the function 1 over 7 minus 10x. Now, after replacing your negative infinity with a variable t, the next thing you need to do is actually work on figuring out the integral. So often what we do is we take an aside and we figure out the value of the integral without the bounds, and then we'll put the bounds back in later on. So in other words, we have to integrate 1 over 7 minus 10x with respect to x. Now it looks like most of these problems will involve u substitution. So what we'll do is let u equal 7 minus 10x. And then what we'll do is differentiate both sides of the equation. So we'll have du equals, the derivative of 7 is 0, the derivative of minus 10x is just minus 10, and then dx. And then I like to solve for dx, so I'll multiply both sides of the equation by negative 1/10. And then, of course, on the right-hand side, negative 10 times negative 1/10 is just 1. So you have 1 times dx, which is just dx. So now we have dx is equal to negative 1/10 du. We can come back now and make substitutions. Remember, we're substituting into this integral right here. So we have the integral of 1 over 7 minus 10x is replaced with u right now. And then this dx is going to be replaced with negative 1/10 du. We can factor out the negative 1/10, leaving us with the integral of 1 over u with respect to u. Most of us know that the integral of 1 over u with respect to u is just the natural log of the absolute value of u. And then finally, we can put our u back in. Remember, u was 7 minus 10x, so we have negative 1/10 natural log absolute value of 7 minus 10x. So that completes the aside, but let's not forget the bounds. They were from t to 0. So what we'll do is we will rewrite our result of integrating, and then we'll put the lower and upper bounds on there. And again, the lower bound was t, the upper bound was 0. We also have to make sure we continue to take the limit as t approaches negative infinity. Next, we plug in the upper bound first, so we're going to put the 0 in first. Notice we still have to write this limit here. So we're going to have negative 1/10 natural log absolute value of 7 minus. Now, we're going to end up with 10 times 0. And that's just 0, of course. So this is really 7 minus 0. Why don't we just call that 7? Keep it easy on ourselves. And then we're going to subtract the result of plugging in the lower limit. So we'll still have the negative 1/10 natural log absolute value of 7 minus 10 times t. So far, so good. Now it is time to let t approach negative infinity. So one way of thinking about that or executing that is to just allow t to equal negative infinity. So in other words, we're going to plug negative infinity in for t. So we'll rewrite the entire integral result here. Now over here, it looks like we're going to have minus and negative. So let's just do plus. We'll have 1/10 natural log absolute value of 7 minus 10 multiplied by negative infinity. Now let's evaluate what's going on inside the absolute value a little bit here. We're going to have absolute value of 7. Now you have a negative 10 multiplied by a negative infinity. That's just going to be a positive infinity, essentially. And then the natural log and the 1/10 here. Now, 7 plus infinity, geez, that's still infinity, because the infinity outweighs by a long shot the 7. The natural log of infinity, that's also infinity. If you want, you can recall the graph of the natural log function kind of slowly rises up as x gets bigger. So as x approaches infinity, the y value also approaches infinity because it kind of increases without bound. So this entire quantity right here is infinity. And this is an interesting result because you're going to have negative 1/10 times the natural log of 7 plus infinity. Now this is a very small negative number. If you're adding that to infinity, it is negligible. So you end up with infinity essentially as your result. And since you have an infinite quantity as the result of integration, this integral is actually divergent. And that completes the answer to the question.